Howdy, AP PreCal. It is Ms. Kosh. One of the tricky things that I have seen in AP PreCal is okay, sorry, I teach you math. Something tricky? Trig inequalities. Okay, and so some people can think through them using the unit circle, but that's a struggle for me. So let me show you how I would think through a problem similar to this. So first of all, they have to give you an interval because with these periodic functions, there's going to be infinitely many places where this is less than something or whatever. So they're gonna limit the world we live in. Okay, so when I start here, that's the problem. The way that I like to begin is to see where they're equal. Okay, and so I'm gonna say cosine of 2x plus partly that way. If I just see where they're equal, then I don't have to worry about did I do anything that would cause the inequality sign to flip, because then I get confused and that's just a problem. Okay, I see cosine, so then I'm going to rewrite this in terms of just cosine. So it's 2 cosine x squared minus 1 plus cosine x is equal to negative 1. Oh, that's convenient. Add 1 to both sides, they're gone. I can factor out a cosine, and then I'm left with 2 cosine x plus 1 equals 0. I did 2 steps at once. Can you see how I factored out a cosine between those things right there? Hopefully, oh, can you see what I'm describing? There we go. Okay, so when is this a true statement? When cosine equals 0 or when cosine equals negative 1/2? When does cosine equal 0? At pi over 2 and at 3 pi over 2. Notice they've already restricted me to this world from 0 to 2 pi. So I just need to go around the unit circle once. Okay, when is cosine equal to negative 1/2? That is at 2 pi over 3 and at 4 pi over 3. Okay, so what I would do is I would come along and draw my number line. We have to live between 0 and 2 pi. And we've put, the smallest of these values is pi over 2. Then the next value is 2 pi over 3. Then it's 4 pi over 3. And then it's 3 pi over 2. If I forget, I can think unit circle. We had this, and this are our values, and, well, 0 and 2 pi. So 0, pi over 2, 2 pi over 3, 4 pi over 3, 3 pi over 2, and then 2 pi. Okay, so some people are able to figure out the inequalities just by looking at the circle, but I struggle with that. So I'm going to pick points. Okay, so I might say, where's that equation again? It's way up there. Let's write it down again. Cosine of 2x plus cosine of x, and is less than negative 1. Okay, so what's something between 0 and pi over 2? Pi over 4. So we might say when x equals pi over 4, I get cosine, what's 2 times pi over 4? Well, that's pi over 2 plus cosine of pi over 4. This will be equal to, okay, cosine of pi over 2 is 0. This is plus root 2 over 2. Is that less than negative 1? No. So we're comparing it to negative 1. This is actually greater than negative 1. So this interval at where pi over 4 would fall is going to give me a false situation. So I'm writing F for false. Okay, now let's say when x equals, what's something between, oh, this is annoying. Okay, so this is a tricky thing because there's not an easy value between, we don't know something from the unit circle that's between pi over 2 and 2 pi over 3. So I'm going to dive right in, and here we go. What we're going to use, this would be what over 12? This would be 6 over 12, and this would be 8 over 12. So 6 pi over 12 versus 8 pi over 12. So 7 pi over 12 would be between them. And now that we have done all of our identities, we know how to find this value. This is going to be a beating. How about we save this for last? Actually, we might have it. We'll have a beating over here also. Fun times. Okay, we're going to save the tricky parts for later. Okay, so now between 2 pi over 3 and 4 pi over 3 is pi. So let's let x equal pi. And so I have cosine of 2 pi plus cosine of pi. Cosine of 2 pi is 1. Cosine of pi is negative 1, and so that's equal to 0, which is greater than negative 1. Does that make sense? Did I do something wrong? I want it to be less than, this is greater than negative 1. Oh, okay. I forgot for a second. To be true, it has to be less than. This is greater than, so this interval is false. Super. Okay. And then this also, we mentioned a minute ago, there's not a whole, I mean, there is something. So we're going to use something between there. This would be over 12. Multiply this by 4 gives me 16 pi over 12. Multiply this by 6 gives me 18. So 16 to 18, so 17 pi over 12 is what we're going to have to use. I'm sorry, you couldn't see me write that. To be in that interval, but not yet. Oh, please, not yet. Okay. And now let's find something between 3 pi over 2, which is here, and 2 pi. How about 7 pi over 4? Okay, so with this one, I have cosine of 2 times that, so 7 pi over 2, plus cosine of 7 pi over 4. Well, cosine 7 pi over 2, think about this for a second. We have 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. Cosine of 7 pi over 2 is coterminal to anything. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and that's all 0. So this is 0 plus this is root 2. The cosine is positive in quadrant 4, and this positive value is greater than -1, which gives us, I had forgotten, but it gives us a false statement here. Okay, so now our expectation is that these two intervals will give me something true. If I knew what the graph looked like, then I could just look at the graph and tell and not have to do anything really gross, but I don't know what the graph looks like, so I need more paper. Okay, we're going to do this entirely without calculator. You ready? Here we go. So now we're looking at this 7 pi over 12 and then 17 pi over 12. We could do the same thing, same process twice. So notice what we have here is we have cosine of, well, 2 times 7 pi over 12 plus cosine of 7 pi over 12. And we're comparing that somehow to -1. Okay. Put a question mark so we know what we're doing. Okay, so this becomes 7 pi over 6, which is convenient. Cosine of 7 pi over 6, we know that value. 7 pi over 6 is over there, so cosine is -√3 over 2. Okay, that's good. But this one, yay, we have to do an identity. This is 3 pi over 12 plus 4 pi over 12. Here's what I just said. 3 pi over 12 plus 4 pi over 12 gives me 7 pi over 12. This is pi over 4. This is pi over 3. Okay, so this becomes cosine of pi over 4 plus pi over 3. The cosine identity is, let's put this in brackets just so we can see what we're working with, is cosine, cosine, sine, sine with the opposite SIGN. And so then it's the first angle, this, that's an S, the second angle, the first angle, the second angle. So the way I remember it, if you find out a better way, share it with me. Cosine, cosine, sine, sine with the opposite SIGN is what I think of for cosine. So I have this -√3 over 2 plus cosine of pi over 4 is √2 over 2. Cosine of pi over 3 is 1/2 minus sine of pi over 4 is √2 over 2. Sine of pi over 3 is √3 over 2. Oh, goodness gracious. Here we go. This is fun. We like this. We like this so much. So this becomes √2 minus √6 all over 4. Oh, guess what I lost? I would lose points, but I caught my mistake. Did you catch it before I did? If so, you're very smart. Okay, so now what in the world is happening? I have, let's give it all a common denominator. This becomes a -2√3 plus a √2 minus a √6 all divided by 4. And we're trying to compare that to -1, and we don't have a calculator. What are we going to do? Well, we know, let's see, we know √3 is between, we know that √3 is going to be bigger than 1 but smaller than 2 because √4 would give me 2. We know that that's also true about √2. But √6 is going to be bigger than √4, which is 2, and smaller than √9, which is 3. Okay, so this is going to be about a negative, this is going to be more negative than -2, because this is going to be a bigger value than 1 times a -2, so this is going to be more negative than -2. This is also going to be more negative than -2. This is, oh man, this is really gross. Well, the whole thing ends up being, this is positive, but it's not that very big. Oh goodness. I did one of these earlier, or a different problem on a different activity, and it was a little more obvious as to compare these guys. What's the best way to compare them without a calculator? Well, at this point, I would probably cut my losses and just say, well, I know it's not these three intervals, and so therefore I assume it's those two intervals because it's probably passing through and all that kind of weird stuff, which is the truth of it. But, oh, goodness. Let's see. I just found a calculator. Let's see. Hang on. Okay. If I plug all this in, I want to prove that this is smaller than -1. We have a -2 root 3 plus a root 2 minus a root 6. Everybody's divided by 4. And that is more negative than -1. We were right. Cold comfort, I guess. Okay, I'm going to clear my calculator because I can see that I'm not in the right mode and I don't remember reset F5, F6, F1, F1. That's how I require my kids to reset. There it is. Okay, and then let's come to the graph. And we're going to type this in. What was our original equation? We had cosine of 2x. Notice it defaulted back to radians. So, oh, you can't see the original equation. Okay. Sorry, cosine of 2x plus cosine of x, and we're going to compare that to y equals -1. And let's see, let's change my window to be trig. Do I like that? I don't know, we're about to find out. Okay, it's almost too much. Oh, look at that. Okay, so let's actually change our window. We restricted our window to from 0 to 2 pi. So I could go from 0 to 2 pi and change my window like that. The y values looked fine. Okay, so in that interval, where is the blue less than the red? Well, it's between those intersection points. With this calculator, G-solve intersect, it's hard to tell that is, what did we say it was? We said that was, oh, that should be pi over 2, and then this next one should be 2 pi over 3. It's hard to tell here, but Desmos is a great friend. Desmos will tell you pi over 2. But you could come back here, menu, come back up to there. You could hit X and enter. And if you think it's pi over 2, then you could say, oh, what is pi over 2? And then be like, it's 1/2 pi. Or like, thanks, Sherlock. I didn't know that. I'm just kidding. Thank you, my little darling. Okay. I can change it to a decimal, and there we go. And we see that that's the correct answer. So the short answer is, that was a beating. The correct answer is, we're on the interval, where are we less than from pi over 2 to 2 pi over 3, and then we pick it up again and we go from 4 pi over 3 to 3 pi over 2. Technically, I needed to do all this nasty work again, but I got down to something that I couldn't quite tell that this was actually less than -1. I thought it might be, but it was hard to tell. So hopefully that was helpful. I probably would have gotten all the way. I would have found these 3 intervals and just picked and looked to see if this was multiple choice and if the other 2 work, and I'd probably pick them and move on with my life, to be honest with you. Okay, like, subscribe, comment, and let me know how I can help you. And in all things, the only way to learn math is to practice.